Good afternoon, everybody. Today is Unit 1, Day 3. What you'll notice right away is that there are no notes. This is kind of a unique piece. And that all I want you doing is watching this. I'm going to keep it nice and tight and then get you on to practice. Today, there are no new pieces of information, but instead of giving you new information, we're going to take the exponent rules that you should already be familiar with, and we're going to combine them together and essentially test your order of operation skills. So let's get right into it. Before we get into those combining, let's make sure that those basics are dialed. First, a review. If you ever see a base, like this 4 right here with no exponent, you can put a 1 on it. All of these things could get 1s. Even the 1 could get a 1. We might not need it, but we could always put a 1 in there. Second, if I have division going on, I subtract 12 minus 1 is 11. So this would be 4 to the 11th power. If I have division going on, I subtract 2 minus 2 is 0, but a reminder that anything to the 0 power is equal to 1. If I subtract 1 minus 9 and get a negative exponent, I have to make that exponent positive by flipping it over into a fraction. And if I start out with a fraction where I have a negative exponent, but it's sitting on the bottom, I flip it again, and it becomes on the top. And the final piece, I guess I should have done this one before that one. If I have one with just a plain old exponent, I flip it and make it positive on the bottom. So that should be a review. It's almost all division, but we're going to do a lot of division in this next chunk because division has a fraction bar, and a fraction bar is a form of a grouping symbol, which is the please and please excuse my dear Aunt Sally. So let's go ahead and start taking a look at our first examples. That's the wrong example, so here we go. So let's begin with example number 1, which is a division problem, but it has 1, 2, 3, 4 different bases. Lied. 1, 2, 3 different bases. That's important. And we have 2 bases that are the same. These 2 bases that are the same, notice they are on the top or the same side of my fraction bar. That means they need to be dealt with first. And here's what I observe. Even though the 5 to the 7th power is in between them, this 4 to the 3rd times 4 to the 5th are essentially side by side with the same base, exponents of 3 and 5. So I'm going to take my exponents of 3 and 5 and write 3 plus 5. The 5 to the 7th, nothing has changed there. And, well, now I'm going to go ahead and add those together, 4 to the 8th and 5 to the 7th. I'll put a dot in there. And the divide by 2 has never really done anything. These bases aren't in common, so there's no simplifying rules. So this is, in fact, all you do for your answer. That's it. Nice and simple. You apply a basic rule, and it takes you to the end. Let's look at the second example. Here again, we see an 8 and an 8 as a base. I'll grab my red Sharpie and add the 1 in there for those who like to have that in there. But here's where we deal with, similar to this one, we have a grouping symbol, and we had to deal with that. Here we have a grouping symbol, a parentheses, and while we could in theory multiply 8 times 8 times 8 together, that's not really our objective. So we're going to leave this alone and move down a layer of the order of operations and do the exponent piece. And that means I'm going to do the exponent of 5 onto this 8 to the 3rd. So here's what I have. I have the 8 with the original red 1. I have the times, and I remember this is 3 times 5. So I have 8 to the 3 times 5 is 15. And now I'm going to, again, apply a different exponent rule. Same base with exponents that are side by side. That's 1 plus 15 or 16. And I'm done. That's all you need to do to answer these questions. Right? So you're going to apply the order of operations. You're going to try and take out the stuff that you can take out to get nice, clean-looking answers. Here comes the third example. I have, again, with 8s, although they wouldn't have to be 8. They could be anything. But in this case, the most important piece is that these are both the same. Well, let's take a look. Our fraction bar separates the top and the bottom. 8 to the 3rd, there's nothing really happening there. So I'm just going to go ahead and leave this 8 to the 3rd. On the bottom, I have 8 to the 3rd to the 2nd. This looks like 3 times 2 to me, so I have 8 to the 6th. And now I have top and bottom where I would divide. I remember the rule, if I have the same base, top and bottom, I'm still going to have the same base. 3 minus 6 is negative 3. And I can't simplify with negatives, so 1 over 8 to the positive 3, and I'm done. Fourth of 5 examples, here it comes. This one has something different going on. I notice that I have a base of 2 and a base of 3, which makes me think I can't really do anything with the 2's and the 3's. And you would be right. But I can do something here and here. So 2 to the, I bet you can figure this out, 6 times 5 is 30. 3 to the 2 times 4 is 8. And because these are different bases, I would not do the subtraction that I did previously. I would just stop, and that would be my answer. Right? Oftentimes when we have different bases, we stop seemingly before you'd think you should, but that is in fact exactly what you do. And our last example, there's a lot more going on here, but again, right off of Get More Math, I have 3 different bases, three bases, all of them the same, so we're going to apply lots of rules here. Let's start with the top, because this division sign, again, this fraction bar is a grouping symbol. It groups the top separate from the bottom. So on the top, I have 9 to the 5 and 9. 5 and 9 make 14. 5 plus 9 is 14. On the bottom, I have 9 to the 2 and 4. 2 times 4 is 8. And now I'm going to apply the rule top to bottom. 14 minus 8, so we have a base of 9. 14 minus 8 is 6. And I'm done. Today, you're going to work on a lot of Get More Math. Most of the problems are going to be almost exactly like this. I wish you the best of luck. And tomorrow, we'll get back into notes.